So today we're going to talk about how do you use a FlySky i4, i3, i6, or i7 receiver and read those signals on a CircuitPython device to have an RC-controlled robot. So let's talk about wiring up your FlySky i6, i4, i3, or i7 receiver. If we come and look on the receiver here, the receiver has two rows of pins. This first row is for an S-bus protocol, and the second row is what we're actually going to be using for our translations. Come over to the side here, we've got a pin out where we've got channel 1 corresponds to this first row, channel 2, 3, 4, 5, 6, all the way up. And then the top row is how we actually provide voltage to the receiver itself. So these are just standard servo pins where this first row here is signal, the middle row is power, and the far row is ground. But the topmost row is going to be providing power into the system, and all these other ones will actually provide power out. So keep that in mind. So I'm going to go ahead and connect a male to female here onto my power, and then another male to female jumper wire onto power, ground there. We'll connect these back to the 5-volt system on our microcontroller. And the ground on our microcontroller. Again, this will only work on 5 volts. Going back, we're now going to wire up for our individual channels. So I'm going to go for channel 1, channel 2. I'm going to skip channel 3 and 4 because I'm not going to be using the left joystick in this project. I'm going to go to channel 5 and channel 6. And again, you could do this for whatever you're looking for. And then we got to connect these to any digital pins on our microcontroller. So I'm going to connect channel 6 to delta 13, channel 5 to 12, channel 2 to 11, and channel 1 to 10. Now to know that we are wired up correctly, we can connect power to our system, turn on our transmitter, and then we should have it connected here. Well, you can see in here, we have our transmitter and then our receiver voltage. So TX is the first one, INT V1 is your receiver, which means we're getting enough voltage. So we are good to go. Something else you can use, if you prefer for wiring, is an Ethernet cable. I just have taken a standard shielded Ethernet cable here, non-shielded twisted pair, and I have just thrown out all the individual channels, plus a power, all out here, and this makes your wiring nice and clean and really simple so you can keep this thing far away from motors that are going to introduce some electrical noise. So let's over to the computer and actually write this up. First thing I'm going to do is import time and import board. The next thing you have to do is you have to import a module that I've written for you. So I'm going to say import RC. And in the description down below, I've included an rc.py file that you need to make sure is on your lib folder here for rc.py. So we're going to create a new instance of our RC class. We're going to say RC is equal to RC dot RC receiver, capital RCR, and it takes 6 arguments. Channel 1 is equal to board.d10. Channel 2 is equal to board.d11. For me, channel 3 is equal to none. So if you are going to not use channels, you have to initialize them as none. Channel 5 is equal to board.d12. And then channel 6 is equal to board.d13. So that is our object initialized. And when we come to actually read our signals, what we're going to do is we're going to say, let's say channel 1 is equal to rc dot read underscore channel, and then you just give it the channel you want to specifically read. Channel 2 is equal to rc dot read channel, and channel 2. Channel 5 is equal to rc dot read channel again, channel 5, and channel 6 is equal to rc dot read channel at channel 6. Now let's go ahead and print what these are actually going to look like. So let's print And I've actually got it easily written in here as a statement already. So I'm just going to print channel 1 is equal to channel 1. Channel 2 is going to be the channel 2 variable. Channel 5 is going to be the channel 5 variable. And then channel 6 is going to be the channel 6 variable. So if I just save this over, I should be able to look at my serial port now. And it should just be printing all of my, if I saved it the right place. Oh, did I spell it wrong? I spelled it wrong. It's EI. Let's try that again. There we go. So now if I look at my, let's just open up my controller here so you can see what it is that we're looking at. Now if you look at serial output, I can see channel 1 move all the way left, bring it down to about 4, move it all the way up to the right, about 94. Channel 2, I'm going to move the joystick all the way up, 99, and the joystick all the way down is about 1. Channel 5 is going to give you a 2-switch system, 0 for down, 1 for up. And then channel 6 is a 3-point toggle switch. So 0, 1, and 2. Now I have swapped these backwards in most of the controllers that I use because I like to have down on. This is not for a drone. Yours might be up for 0 and 1 for down, depending on how you have this and how you've got it wired up. But that's it. Oh, one more critical thing that you're going to need to know. Occasionally, this system will return none, because what will happen is you'll get a bad read occasionally because we are translating some PWM signals. If anyone knows of a better way to translate a pulse width modulation signal into something better in CircuitPython, please let me in the comments down below. But this seems to be the best way that I've been able to find that works. If you want to actually do something with these values, like let's say you wanted to have, like you had a servo, and you were going to say servo.throttle is equal to channel 1, you wouldn't want to run like that because occasionally channel 1 will return none. And if it returns none, you cannot say that a servo throttle is equal to none. It only accepts an integer variable, and that's going to throw out the values of your project. So what I like to do is I'm going to say if channel 1 is not none, then you can actually say servo.throttle is equal to channel 1. So that's going to allow you to actually do something with your value. In terms of where these values go, channel 1 is going to give you between 0 and 100, with 50 being the midpoint. Same thing with channel 1, 2, 3, and 4. That is the same for channels 1 through 4. Channel 5 is going to give you either a 0 or a 1. And channel 6 is going to give you a 0, a 1, or a 2. So again, if you're actually going to use these numbers as strict numbers, you're going to have to make sure to check that your channel rating is not currently none, and then you'll be able to run it up. So that's how you read the FlySky controller in CircuitPython. If you want to know how you can set up a 2-motor tank-style arcade drive Rover, you can take a link to that in the description down below as well. And best of luck with your next robotics project.